In the hidden world beneath our feet, the ant colony is a marvel of order and cooperation. At its heart is the queen, the mother of all her subjects, tasked with a single, vital purpose: to continue her own lineage and ensure the survival of her species. We've long believed that her loyalty is absolute, that she would only ever create offspring of her own kind. But nature, in its infinite creativity, has revealed a startling exception. Deep in the sun-baked soils of the Iberian Peninsula, a species of harvester ant has been found to be breaking this fundamental rule of life, a discovery that challenges everything we thought we knew about the boundaries between species. It's a tale of a queen with a truly remarkable and unexpected secret. This extraordinary behavior was uncovered in a species of harvester ant known to scientists as Mesobarbarus. The queen of this colony does something previously thought impossible. While she dutifully lays eggs that will become her own daughters and sons, she also holds onto a strange power. She can take the sperm from a male of an entirely different species, Mesor capitatus, and use it to father some of her male offspring. This is not a mistake or a rare accident, it's a deliberate and consistent strategy. The queen is, in essence, borrowing the genetic material from a neighbor to create foreign sons that live alongside her own true-born family within the same nest. Imagine a single ruler governing two separate nations under one roof. That's what we're witnessing. The queen carefully manages this delicate balance, producing males of her own species to carry on her genetic line, while also raising these alien males from another. The very idea is astonishing. It's as if a lioness were to give birth not only to lion cubs, but also using the seed of a tiger to tiger cubs in the same litter. This peculiar arrangement, where a mother gives birth to offspring of another species, has been given a new name by scientists to describe its uniqueness: Xenoparity. It's a term that captures the sheer strangeness of this parental miracle. This discovery forces us to look at the ant world with fresh eyes. The ant colony, often seen as a perfect model of genetic purity and singular identity, is suddenly revealed to be far more complex. The queen is not just a mother, she's a master strategist, manipulating the very fabric of life to her advantage. She is a pioneer, blurring the lines that we as humans have drawn to define what a species is. This Iberian queen's secret is a profound reminder that the natural world is always full of surprises, and that even in the most familiar of creatures, there are new and wonderful stories waiting to be told. So, how does this queen perform such a feat of genetic wizardry? The process is both simple and profoundly clever. Like many ants, the queen stores sperm from her mating flights, which she can use for the rest of her life. A Mesobarbarus queen, however, mates with males from her own species and also with males from the rival Mesor capitatus species. She then holds the sperm from both in separate storage compartments. This gives her complete control over the parentage of her children. When she wants to produce a daughter, a future worker or queen, she uses sperm from her own species to fertilize an egg. This is the traditional way, ensuring her own legacy continues. But when it comes to producing sons, her strategy becomes truly unconventional. Ant males, or drones, develop from unfertilized eggs. They normally have only the mother's genes. However, this queen can choose to add sperm from the foreign Mesor capitatus male to an egg destined to become a son. This sperm does not fertilize the egg in the usual way to create a female. Instead, it somehow ejects the queen's own genetic material from the egg and replaces it. The result is a male ant that has no genetic connection to the queen who laid the egg. He is, for all intents and purposes, the pure-blooded son of a Mesor capitatus father. This act of genetic replacement is a biological masterstroke. The queen effectively acts as a surrogate mother for another species. She lays the egg, but the genetic blueprint inside belongs entirely to her rival. This means that within the bustling corridors of a single Mesobarbarus colony, two distinct types of males are raised side by side. There are the native sons, who carry the queen's genes and are ready to mate with new queens of their own kind. And then there are the foreign sons, genetically Mesor capitatus, who will fly out and mate with capitatus queens, unknowingly spreading the genes of a rival species. The precision of this system is what makes it so breathtaking. The queen is not simply mixing genes at random, she's making calculated decisions about which sperm to use for which egg. She is a genetic gatekeeper, deciding which lineage will be passed on with each birth. This level of control over reproduction is incredibly rare in the animal kingdom. It demonstrates a sophisticated evolutionary strategy that allows the queen to manage the genetic makeup of her colony with unparalleled finesse, ensuring she produces not only her own offspring but also the offspring of another species, all according to her colony's needs. While the queen produces pure-blooded males of two different species, the story of her daughters is just as remarkable. All of the female workers in the colony are hybrids. They're created when the queen fertilizes her eggs using sperm from the foreign Mesor capitatus males. This means every single worker ant, the backbone of the colony, responsible for foraging, nursing and defense, is a blend of two species. They carry the genetic inheritance of their barbarous mother and their capitatus father. This is a complete departure from a typical ant colony where all workers are pure members of the queen species. This hybrid workforce appears to be the key to the colony's success. Scientists believe that these hybrid workers possess a special quality known as hybrid vigor. By combining the genes from two different species, the offspring can end up being stronger, more resilient, or more efficient than either of the parent species. These hybrid workers might be better at finding food, more resistant to diseases, or hardier in the face of environmental challenges. They are the engine of the colony, and their mixed genetic heritage gives them an evolutionary edge, allowing the entire colony to thrive in a competitive world. The queen's strategy is therefore a two-part marvel. She uses the foreign males to create a superior hybrid workforce of sterile daughters who will build her empire. At the same time, she uses her own unfertilized eggs to create pure-blooded sons of her own species who will carry her genes into the next generation by mating with new queens. It is a perfect system. She outsources the labor force to hybrids, reaping the benefits of their strength, while ensuring her own genetic line remains undiluted and continues through her pure sons. This is a level of genetic manipulation that is both brilliant and ruthless. This division of labor and genetics is what makes the discovery of xenoparity so significant. It shows us a colony that functions not as a single genetic entity, but as a complex alliance between different genetic lines. The queen is the central figure who orchestrates this alliance for her ultimate benefit. She leverages the strengths of another species to build a powerful and robust colony, all while safeguarding her own precious lineage for the future. The hybrid workers are the disposable, yet essential tools that make this incredible balancing act possible, a testament to the strange and wonderful paths that evolution can take. The discovery of Xenoparity in these Iberian harvester ants fundamentally changes our understanding of what a species is. For centuries, we've defined a species as a group of organisms that can breed with one another and produce fertile offspring, while being reproductively isolated from other groups. This ant queen, however, completely ignores that boundary. She actively uses a different species as a genetic tool, incorporating its DNA into her colony in a highly structured way. This isn't just accidental hybridization, it's a stable evolutionary strategy that relies on the existence of two separate species. This finding suggests that the lines between species can be much more fluid and interactive than previously imagined. This phenomenon forces biologists to reconsider the very concept of family and kinship within the animal kingdom. In a typical ant colony, every member is closely related, working together for the good of their shared genes. Here, the colony is a mosaic. It contains a pure-blooded queen, pure-blooded sons of two different species, and hybrid workers who share a mother but have fathers from a rival species. This complex web of relationships challenges the idea that cooperation is driven solely by shared genetics. It shows that a colony can function as a cohesive unit even when it is composed of such genetically diverse individuals united only by their service to the queen. The implications of this discovery extend far beyond the world of ants. It serves as a powerful reminder that nature is constantly experimenting, pushing the boundaries of what is possible. Xenoparity could be happening in other creatures, hidden from our view. There may be other species that have found ways to borrow, steal, or co-opt the genes of their neighbors for their own benefit. This finding encourages scientists to look for similar behaviors elsewhere in the tree of life, opening up entirely new avenues of research into evolution, genetics, and the complex dance of life and reproduction that shapes our planet. Ultimately, the story of the Xenoparity ant is a story of wonder. It reveals a layer of complexity in the natural world that we were previously unaware of. It shows us that even the smallest creatures can possess strategies of breathtaking sophistication. This discovery enriches our appreciation for the endless creativity of evolution and highlights how much we still have to learn about the intricate workings of life on Earth. The ant queen in her quiet, subterranean kingdom has shown us that the rules we thought were written in stone are, in fact, merely suggestions, and that nature's true genius lies in its ability to break them.